Episode 201 of CppCast with guest Michael Park, recorded June 5th, 2019. Sponsor of this episode of CppCast is the PVS Studio team. The team promotes regular usage of static code analysis and the PVS Studio static analysis tool. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we discuss initialization syntax in C++. Then we talk to Michael Park from Facebook. Michael talks to us about his proposal to add pattern matching to C++. Welcome to episode 201 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm all right, Rob. Made it to 201.
Made it to 201. It's going to take a little getting used to start saying...
Can you count that high?
Yeah, I wonder if it's going to be another big milestone when we hit a full byte. It's 256.
Or 255?
255, yeah.
Well, we should have started counting from 0. I really wish that I had started my videos from, like, 0 count and, like, octal or something. That's what I wish I had done.
Yeah, that'd be nice.
Yeah, it's too late now.
Too late. Well, at the top of the episode, I'd like to read a piece of feedback. We got a bunch of tweets last week after we released episode 200. This one is from Luke Trevorrow saying, episode 200 of CppCast, Herb Sutter was a joy to listen to. Congratulations to Rob and Jason for making it to 200 quality podcasts. Don't ever give up, which is a reference to us talking about how much longer we'll keep this thing going. But yeah, as long as there's... C++ news to talk about. We don't have any plans to end it anytime soon. Yeah.
And now, I just, is it fair to say 200 quality episodes? Could we say like it's at least like 170 quality episodes or something?
We were definitely still learning early on, but I would hope to think that the vast majority of them have been quality episodes.
Yeah.
Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Michael Park. Michael is a software engineer at Facebook working on the C++ libraries and standards team. His focus... Joining us today is Michael Park. Michael is a software engineer at Facebook working on the C++ libraries and standards team. His focus for C++ is to introduce pattern matching to facilitate better code. Michael, welcome to the show.
Hey, thank you. Thank you for having me.
So how long have you been at Facebook?
I started April last year, so like a year and a bit.
Okay.
Yeah.
I feel like we've had like many Facebook developers on here over the years.
Oh, cool. Yeah.
Yeah,
Victor went on recently, I know.
Yeah, and you always have a pretty good presence at conferences from what I've seen, too,
Yeah.
right?
Yep. CppCon especially, I think we have a lot of people going.
Right.
Mm-hmm.
Okay. Well, Michael, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll talk more about pattern matching, okay?
Great.
Okay, so this first one is a blog post from Timur Dumler. I know I've met him from JetBrains, but I have trouble with that name. and this is a post, Initialization in C++ 17, which comes from a talk he gave, and he just had a lot of requests for this one slide he made on all the different types of initialization that you can do in C++ 17. And it's quite a little chart, isn't it?
It is. Yes. And you've definitely met him because he goes to all of the C++ conferences. Without realizing it, I think I've met him in like 5 different countries now or something.
Yeah, I know we talked to him along with Anastasia and Phil at the at CppCon last year. Yeah,
Both of whom I've also seen at 5 other countries. Yes.
right. But yeah, is there anything you want to call out with this chart, Michael or Jason?
42 entries. I noticed that. That's interesting. 40,
I did not notice that.
there.
That's funny.
That's funny. Yeah, I think it's a useful chart for people. I think that some of the entries actually kind of are confusing to me. Like the box for default initialization for aggregates, for example, it says uninitialized. But I mean, like, if we have, a struct X with a string in it, and you default initialize that, that's not uninitialized. It's going to default construct the members, which is exactly what it says for the other types with no user provided default CTOR row. Under default init, it says members are default initialized. So like that seems to be the exact same case for aggregates for default initialization. So I'm not exactly sure what's going on there.
So I think the point is if you had like a struct of 3 ints,
yeah,
and that first column, all their values are undefined.
Right, that's true. But it's very much dependent on what's inside the aggregates, right? And so
yes, I would agree.
So it's kind of interesting. Like if it said aggregates with default, aggregates with built-ins only or something like that,
or trivial aggregates or something like that, maybe.
Something like that. But
yeah,
it's just aggregates, and so it's kind of like, I don't know what the. I think I understand what it's trying to say, but maybe it's just a slightly inaccurate or something. Yeah, and it also says like copy initializations for aggregates doesn't compile. But I mean, if I have a struct X with an int in it, like I can copy initialize one just fine. So I'm not sure what's going on there either. So I have a few questions, but in general, I think it's a useful table for people.
Yeah, I feel like it must just be like what could fit in the square. Because like if you had a struct of an int and you do equals 5 because he has, equals value there, that wouldn't compile, right? Because it doesn't have a constructor or a conversion operator or whatever that it could call.
I guess that's what it means. Yeah.
I think that must be the point. Yeah. So it's
Yeah, but initialization is a crazy area that I actually kind of like stayed away from for a while, just because I don't want to see all the stuff under the hood. But I see like common mistakes, like people doing like array, initializing an array with like curly brace 0 close curly brace, thinking that 0 initializes the array, like if it's like an int array or something, and like it happens to work, right? Because it'll take the 0 value and then 0 initialize the rest. But if people put like open curly 1 close curly, thinking that it initializes all of the values to 1, like that is not what's going to happen.
Right, initializes the first value to 1 and the rest of them to 0, right?
Exactly, yeah. And so the curly 0 close curly is like very misleading as to what's actually happening there.
Yeah, that's a great point.
And I see that all the time.
I think I will use this chart like in my classes. I mean, just like tell my students that this chart exists.
Mm-hmm.
But when it comes up sometimes in classes and teaching, I'm like, yeah, there's like 17 types of initialization in C++, but we don't really care. These are the 3 rules that I want you to pay attention to.
Yeah. I mean, we try to like shove it under some sense of intuition, right? And hopefully it comes out okay, but all the nitty-gritty is pretty ugly.
Yeah, that's true.
Okay, next thing we have here is another update from Visual Studio 2019, and this is CMake 3.14 and performance improvements. So we talked about this a fair bit, how they keep improving their CMake experience with Visual Studio. And with this one, it seems like the main improvement is that they upgraded to CMake 3.14, and with that, they can now use the file-based API. Jason, are you familiar with what that gives you?
I am not. I read this, and at first I was like, wait, where are these performance improvements coming from? Oh, that's because of a change in CMake. But then I noticed that they said CMake had deprecated the CMake server, which I thought was interesting because there's a very brief period where like all of the build tools and compilers were like, we're going to stand up our own servers and everyone can talk to the server and they can get all the information that they want. And then they're like, never mind.
Right.
So apparently, CMake server is no longer being used, and now there's this file-based API that I'm not familiar with.
Neither am I.
Okay. Well, it seems like it's a good move, and if you're getting performance improvements out of it, it's definitely a win.
Well, yeah, we didn't actually. I don't think you said out loud. It's 2 times performance improvement for CMake-based configurations.
Yeah.
Yeah.
Yeah, it looks like they tested it on the LLVM code base.
Which counts. I mean, that's a large CMake project.
Oh, yeah.
That's what I'm trying to say.
Yeah.
It's not like testing it on my toy project or something. Yeah.
No, absolutely not.
Yeah, I'm sure it's a good test case. Yeah. Okay.
I think it would actually be.
Go ahead.
I think it would actually be even like more impressive if it was on a small project, because I think oftentimes it's harder to get big wins on small projects.
Oh, right. I mean, on the upside, a small project doesn't have a measurable time when loading CMake. Hopefully.
Yeah.
Hopefully.
Right.
Yeah. But it seems pretty impressive.
Yeah.
Okay, and then the last thing we have is Compiler Explorer released a beta version of code execution support. So you can now actually see the code you put into Compiler Explorer and see what the output would be from that code when you run it, in addition to the assembly and all the other good stuff that Compiler Explorer already did.
Yes. So
Go ahead.
Well, I was going to say, for background, for people who watch C++ Weekly, I've been showing this support for years. Because if you run it locally, you've been able to do execution with no problem. But Matt just had the time and opportunity to be able to, with some level of, assurance that it's not going to take down his whole server, put this up on the official website now.
Gotcha. Okay, well, Michael, can you start off by maybe giving us an intro to what exactly pattern matching is? I'm sure we've referenced it a couple times when talking about other languages on the show, but I don't think we've ever gone in depth with it.
Cool. So pattern matching basically is a declarative approach to inspecting a value or values, in that rather than using something like a if-else chain where you would poke into a given value to check its state. So for example, if you have like a point class, if you were to check whether this point is in the origin, you would often end up writing something like if point.x equal to 0 and point.y equal 0. Right?
Okay.
And so we have some value and we're reaching into that value to check some conditions, right? Mm-hmm. And oftentimes these conditions are capturable in what we refer to as a pattern. And so a pattern generally is a description of a value, and patterns they either match or they don't match, right? And so in this case, we would introduce a pattern like square bracket 0, 0, close square bracket, which would capture the idea of first element 0, second element also 0. And this also has to be a 2-tuple kind of thing. And so you can view pattern from so similar terminology comes from regex, right? Where you have the regex pattern, which is a description of the string that you're looking for, and then we just say, oh, given some arbitrary string, see if this pattern matches that string. And then if it matches, then you can actually specify which components of that string you want, which will then give you your regex matches, which is your capture groups essentially, right? And so we can do something similar with generalized beyond strings, where we can say square bracket 0, x, close square bracket, where the second x captures the value of the thing that we matched, right? And so what ends up happening is you end up writing like a switch kind of language construct. And rather than having cases that are constants or integral constants, you end up being able to do a lot more elaborate things in there. And then it'll match the first pattern. It'll dispatch to the statement expression that first for which the pattern first matches.
So you said, a lot more things. Like, what exactly can I put in there? Like, I don't know. Can I say if x is greater than 5 and y is less than 4, and that's one of my cases?
So that would be provided through what we call a pattern guard.
Okay.
And so there essentially would be a small pattern language, right? So the square brackets, which is kind of like inherited from the structured bindings notation. After, let's say, for example, I want to say, so let's go back to the point example, right? If we say I want to match a point of x comma y, and then I want x to be greater than y, right? Then you would say open square bracket x comma y close square bracket if x greater than y.
Okay.
And so you can put an if statement essentially after a pattern inside which you can put arbitrary Boolean expressions again.
Now, this syntax you're talking about, you have a pattern matching library, and we didn't, I don't think, mention yet that you have a pattern matching proposal. This syntax you're talking about is in reference to the proposal?
This syntax is in reference to the proposal, yes.
Okay.
Yeah. Mm-hmm.
So maybe we should dig into that a little bit. I mean, you also do have the pattern matching library. Is the library based on your proposal? Is it like a sample implementation?
No, the library actually came before the proposal.
Okay.
It was an experiment. It was an experiment to see how far we could take a library to see. Well, it was twofold. One was, could a library solution be enough? And the second was, if it's useful but it sucks enough, then similar to Boost Lambda, there would be some desire to actually make it a language proposal because it's not sufficient, right?
I'm sorry, but you just mentioned Boost Lambda. For our listeners who are not familiar with it, it is completely unusable.
But it was useful enough, people wanted it, but it sucked enough that we wanted a language thing, right? And so
right.
That's the balance we want to strike there. But yeah, it was. I gave a talk on it in CppCon 2017, describing the challenges that I hit with it, namely around identifiers. Basically, it was pretty difficult trying to introduce identifiers inside a pattern because there are only so many contexts in which you can introduce an identifier in C++. And so inside of the pattern, which is essentially just a value with the placeholders, which I called arg, because the placeholders inside the pattern in that library would get dispatched to the lambda, which is on the right-hand side.
Okay.
And so, again, going back to the point example, if I were to say something like, product type like DS, which stood for destructuring, if you were to say DS open paren arg comma arg close paren equals a lambda that takes 2 arguments, when that pattern matches, the 2 elements of the pair would get dispatched to the lambda on the right hand side.
Okay.
And so it of course hit a readability issue because when you have complex patterns with arg like you have no idea what those are, right? We really want identifiers in place to be able to help denote what those fields are. And so what we end up doing then is like, okay, auto name equals arg, auto address equals arg, and then put those names inside the pattern. But that has to be declared beforehand, before you actually use it.
Right.
Which is like, it defeats the purpose of the whole thing. So Yeah.
So,
So
how is? I'm sorry. No, go ahead.
yeah, so I think so. I think as an experiment, it was a pretty successful one. It definitely helped to guide the language design quite a bit. Um, but I think we need something more than library solution.
Is the library used actively by anyone right now that you
Uh,
know of?
I hope not.
That
um,
might be the first time we've ever had a library author on our show say, "I hope no one's using my library." I like it.
there has been, I mean, because I put zero effort into optimizing it, the actual
Okay.
performance of it was really an experiment for uh, to explore the API space.
Right.
Uh, and I think I mean, okay, so to be honest, there are some people who are using it in their like school projects or something like that because they're writing a compiler in C++ or something and they want to have pattern matching because it's pretty useful in that context. Um, but like they don't, it like performance doesn't quite matter for them. And so
Right.
that's the context in which I was saying I hope no one's using it.
That's awesome.
Yeah.
Well, I guess let's talk more about the pattern matching proposal. So you said it is kind of informed by the work you did on your library. Who
Yeah.
else is authoring the proposal? Like, what's the current status of it?
Right. So there are three co-authors on the proposal: David Sankel, Sergey, and Dan Sargensen. Um, and those guys are at Bloomberg. So the latest paper actually the preceding one was from David Sankel from 2015, I believe. He proposed language variant as well as pattern matching in a single paper back then. And the feedback from the committee was to separate the proposals into two different things. And after that, I went and implemented this library to get some experience. And then he and I, well, all four of us. So the other two co-authors joined David through because they work in Bloomberg. And then we had competing proposals initially, and then we kind of, got together and figured out how to
Combine them.
combine them. Yeah.
Okay.
So that's how it kind of came to be. The latest status of the paper itself is that we presented it to the evolution group on a Saturday session in Kona. That was back in February, and we're going to be scrambling for the next 2 weeks because that's when the Cologne deadline is. So the next mailing for Cologne, which the meeting will be held in July, but the pre-meeting mailing is due 2 weeks from now.
Oh, wow. Okay.
2 weeks minus 2 days. So so we have
So
like
that's
11 days or so. Yeah.
for our listeners. When this airs, that means they'll have basically 2 weeks to get if there's any papers they're hoping to get to Cologne. Yeah.
Yeah, something like that.
So you're not targeting C++ 20 though. Are you trying to get this into C++ 23?
Yeah. So it's targeted for 23. 20 is feature complete.
Right.
It's just issues coming back and stuff like that. It's very early in its stage still. There's not a full implementation of it. There is, the implementation that was done in my library as well as a library like Mach 7, which was library that was done by Yuri. Yuri Solotsky, I believe, is how you pronounce his last name, but I'm not 100% sure about that. So Yuri, as his PhD work, I believe, did Mach 7, which was a pattern matching library that used macros and such. But he did a lot of work in actually implementing optimizations for getting performance that matched virtual dispatch, basically. And so there was a lot of performance work that was done there that I think we'll be able to draw from as well. But yeah, this is definitely headed for 23. Yeah. I hope it'll actually be one of C++23's marquee features. We'll see how that goes.
I mean, it sounds potentially like it would change a lot of code, but I think we should kind of, I guess, dig into it some more.
Yeah.
So you mentioned that you can basically do destructuring and then have a guard.
Yep.
And I believe looking at the proposal, you can also match on types.
Yes.
Okay. What else can you do?
Yeah, how exactly would the type matching work?
Yeah.
Sorry, I didn't hear what Rob said.
How exactly would the type matching work?
Yeah, so the type matching happens through angle brackets. The primary use case is to match std variant. So there have been several complaints about the API of std visit as well as performance of std visit. I may have heard more of that than others because I implement. I have an implementation of variant, and so people come to me with visit issues. But basically, the API for visit is kind of backwards, right? We have to first list the cases that we want to handle in a function object or something like that, and then we have to say std visit of that function object, comma, sequence of variants that you want to match. And so oftentimes we end up doing a single visitation, so it ends up being like visit function object, comma, visit variant, as opposed to what people are more used to is the switch kind of syntax, where we should be able to just say, switch on a variant and then list the cases that you want to handle. If those happen to be types, that's fine. And so what we want to allow is for people to say something like inspect v, where v is some variant, and then angle bracket int, angle bracket string, etc. Right? So those are the cases in your inspect statement. And so the way that would work is you end up visiting the variant and then checking that the resulting value actually matches that type.
Okay.
And if it does, then it would dispatch that handler.
So is it kind of like structured bindings where there's hooks so that you can implement your own thing to like decide what the type of this object is or whatever?
So the customization points for variant would be variant variant size, variant alternative, and get.
Okay. And it relies on those already existing customization points?
Yes.
Okay.
Well, those are not customization points today, per se.
Oh. Okay.
But tuple size, tuple element, and get are for structured bindings. And so it's kind of a similar mapping to variant. So what would actually end up happening in the kind of like pseudo-translated C++ code would be you would do std visit on a generic lambda. And then inside the generic lambda, imagine you have a sequence of context per ifs where the checks are the type of the thing that came in is the type that we're trying to match.
Right.
And so it doesn't quite have the semantics of std visit with an overloaded set with int and string, right? Because if you were to match a double, then with the pattern matching proposal, that wouldn't match. Whereas with overloaded function object, it would convert and match. And so it has slightly different semantics.
Okay.
But in terms of the mechanisms, that's how it works with them.
Okay. So it would be extensible for other user-defined types, not just variant.
Yes.
And does it work with RTTI for dynamic types?
Right. So for polymorphic types,
sorry.
Yeah. The idea is that it would perform sequential dynamic casts semantically.
Okay.
Not implementation-wise. Implementation-wise, we can do tricks that were explored in Mach 7, which actually like caches the result of dynamic cast and stuff like that, which comes out to be pretty impressive numbers.
Really?
Yeah. Yeah, the paper is actually super interesting. It stashes a B table pointer and like uses that for something. I don't remember the details exactly, but yeah, there's some interesting stuff there. There's like a pseudo Duff's device thing in there that like stashes stuff. And, yeah. So it wouldn't actually be sequence of dynamic cast, but it would be semantically that's what would happen.
Okay.
And so there are some nasty cases because dynamic cast allows weird things like crosscasts.
Right.
And so this is one of the things that's difficult is people intuitively look at examples and think, especially the variant examples, and think like, oh, why don't we just do best match here when we just have we're matching types. But the issue is that even if we're doing types for polymorphic types, for example, we can't really do best match. That's not really an option. And so we have to do linear search.
Right.
And I think like even though we could do best match for variant, it would be very confusing if these two very similar things have different semantics. I think it would be much simpler for people to look at it and say, okay, we just do first match, and that's
right.
That's all I have to know. So those are the customization points. It's tuples, the tuple-like protocol, structured bindings, the variant-like protocol for variant-like stuff, and the third one will be like an any-like, and so like dynamic cast is the any-like thing, polymorphic types. But if I listed any, for example, and I wanted to match a sequence of type-based matching, then you could call any cast for each of them.
That sounds potentially very handy because otherwise any is kind of a bit wordy to work with.
Right, exactly. And so the customization point for that currently is any cast, but maybe it should be did cast or something neutral.
Right.
Yeah. So those are kind of the user-defined type customization points. But it gets more interesting because we can actually support user-defined patterns as well. And so this was something that I covered in my talk at C++ Now, which was from which I actually got an audible wow from one of the members in the crowd. So
that's always fun. Yeah.
Yeah. So CTRE, which is compile time regular expressions.
Hannah's library. Yeah.
Hannah's library. Yeah, it's gotten pretty popular. One of the things that it can do is it can tell you the size of the match, the resulting matches at compile time. Right. So with std regex, if I were to do a match, the thing that I get back is something like a vector of string views essentially.
Right.
Right. Whereas with Hannah's library, I get an array of string views of some compile time size.
Okay.
So what you can do with that is you can say CTRE of some string, some regex pattern that match on some string, and then the result comes out to be some fixed size array. And so I can immediately decompose that with structured bindings. Right? And so for example, I can have a date regex, and I could say that date regex dot match of some string, and then I can on the left hand side I can say square bracket auto square bracket the entire match, comma, year, comma, month, comma, day, close square bracket equals the regex match thing.
Okay.
And you can use the year, month, day immediately.
Right. That's pretty cool.
Yeah. So that's really nice. And so if you were to put this into the context of pattern matching, then if we were to want to test a string to see whether it's a date, test whether it's a phone number, and then do different things based on it, then now we need to we say like inspect S, and then what do we do? Like we have a date regex, but we can't match the date regex with the S and then match on it immediately or anything, given what we've just talked about so far.
Okay.
So what we introduce is a notion of an extractor. So an extractor takes a value, calls extract on that extractor with the value, and then we pass on the result of that into a subsequent match, a subsequent pattern match. So we say something like extractor question mark pattern.
Okay.
Okay.
Trying to visualize it all, yeah.
Yeah. So let's say the extractor is like a date regex. So we say date regex question mark square bracket year month day.
Right. Okay.
So what that would do is take it would call date regex dot match on S, try extract on S.
Mm-hmm.
That would return some array, and then that array would be matched against the square bracket year month day, which is on the right hand side.
Right.
And then if that matches, then you can then on the right hand side you'd have access to year month day to use immediately.
Okay.
And so you could do a sequence of these basically.
Right.
Right. And you can check if the string is a date, then do this, and if it's a phone number, then do it this with the area code or whatever.
So instead of a bunch of nasty if statements together,
yeah,
combining with CTRE and your pattern matching, you'd be able to do a nice clean table of all the different options.
That's exactly right. Yeah.
Okay.
Yeah.
Sounds very nice.
Yeah. Yeah. So that was pretty cool.
I'm kind of curious about two things, if you don't mind. In the cases where like you do type matching, and you said that it's as if you had done an if const expr, or if you had done a dynamic cast or something in there, that does kind of imply like there has to, I don't know, I feel like there has to be some kind of case where it's handling the fact that there might be different types inside here, and the code that you're passing in is not necessarily be valid for all types that are matched or all context or something. I don't know. Like, it does feel like it does have to effectively do an if const expr and any of the things that do type matching. But that can't be right for the types that are runtime known. Never mind. I might just be overthinking this, so we can move on past that.
Okay. Okay. So to be clear, patterns do have requirements that are placed on the subject, which is the thing that's being matched.
Okay.
So for example, similar to how structured bindings, if you were to do square bracket x comma y equals some expression, the expression is expected to be tuple size 2 with get 0 and get 1 valid get 0 and get 1.
Right.
And so like those requirements are placed on the value that's being matched by any given pattern.
Okay.
And so
yeah. I guess what I'm trying to ask is the thing on the right-hand side, unlike a switch statement where there is no new scope, the thing on the right-hand side is a new scope. It has its own types. It has its own context, whatever. Like, it's its own thing. It's not just...
The right-hand side has its own you mean the right-hand side of like a
of the match.
Case,
yeah,
right?
like the actual operation you're going to perform, I guess.
Right. So that doesn't have a type.
Right. Okay.
So there are two forms of inspect that we're proposing. One is an inspect statement, and the other is an inspect expression.
Okay.
So the first form is an inspect statement, which is very much like a switch, where the right-hand side is a statement, and so there's no type.
Okay.
But it does
there's no new scope or anything right there.
There is its own scope.
Okay.
Because we need it for the names that are being introduced in the pattern.
Right. All right. Okay.
Yeah. And so it does have its own scope. In the expression case, it also has its own. It also has a type.
Okay.
And so the expression statement uses a equals greater than, which is a fat arrow, essentially in the middle instead of a colon.
Okay.
But an expression is very very useful because otherwise you end up doing every case having a return statement and wrapping that whole thing in a lambda and specifying return types and etc. And then immediately calling it and stuff like that. Right?
Okay. And thinking about it kind of in the context of a switch statement, is there a default case?
Yeah, so the default case essentially would be okay, this is an interesting part actually that we have to discuss during the meeting, which is the underscore.
Okay.
Which is a pattern that matches anything.
Okay.
But if you look at it, like any identifier matches anything, right? It just binds whatever is being matched. And so if you were to just put foo as the pattern, that would match anything and just give it an alias foo for the thing that's being matched, right?
Okay.
And so you could just use underscore in that way, where underscore just introduces a new variable, a variable name, because it's a valid identifier today. Right, but what that means is you couldn't do something like square bracket, underscore, comma, underscore, close square bracket.
Right.
Because I have a redeclaration issue.
Yeah, and people have been wanting to skip structured binding elements forever doing something like that. Yeah.
Exactly. And so we brought a proposal to Kona. I think the number was P1469. Which was to propose disallowing use of underscore in the context of structured bindings, so that we could use it to ignore stuff in structured bindings, but also in pattern matching. And that did not fly. And people didn't want to, because it's an already existing variable, people didn't want to introduce context sensitiveness into it.
Although technically a variable that's just underscore is reserved by the standard anyhow, right? Because anything that starts with an underscore, variable that's...
No, that is not true. Underscore at the global namespace is reserved, but not inside namespaces.
It is underscore followed by a capital letter is reserved everywhere.
That's true.
So
underscore anywhere in your identifier is reserved, but underscore followed by a small case
is not. Yeah,
lowercase is not
in a local scope.
Yeah.
I still don't do it though.
Yeah. But the issue basically is popular libraries like Google Mock has a Google : testing : underscore, which is passed to their framework to indicate I don't care what gets matched here. And so in Google Mock, you can say stuff like, expect this function to be called with these arguments. And so you might say like expect call foo, 1, 2, and then you call foo with 0, 0, and then the variable will tell you, oh, I expected a call to foo with 1, 2, but you passed it 0, 0, kind of thing. And if you didn't care what the value was for one of those things, you could pass underscore, which is their placeholder, which is an actual value there, but their library knows how to interpret that to ignore those values. Right, and so because of these existing uses of underscore, we couldn't quite make that the otherwise case, which should have served as the default case as you were asking about.
Okay.
So we need some different way to spell it. There has been some discussion of double underscore, which I because it's already reserved, right?
Which is definitely reserved, right?
I hate it. I think it's a terrible way to go. But I don't know. Question mark has been mentioned. But
there's always triple underscore.
Yeah, I did have a silly idea of allowing 2 or more underscores, at which point you could actually, if you have a table of like square bracketed, structured bindings looking matches, you could actually like use, 7 underscores if you need to align your variables properly.
Right.
But yeah, so I don't know. We'll see what happens there. But question mark has been brought up as an option, but I think that would be challenging. I think there are various extensions for like question mark colon. I think there's a GCC extension that does question mark colon. And so like if you were to use that as a default case, you would end up with question mark colon stuff, right?
Okay.
And that might be an issue. Yeah. C++ grammar is crazy. So, yeah.
Well, yeah, yes. I mean,
Yeah. Sorry, go ahead.
I think, students at one point recently asked why lambdas have the syntax they do, and I was basically like, because it was the only option left. I mean, that's not 100% accurate, but I think it's pretty close to the truth, actually.
Yeah. Working on this proposal, I really feel like I got myself into a 35-year-old Jenga game. and yeah, it's pretty challenging. Like, where do I poke? Is this thing gonna fall? I don't know.
Is there any like particular use cases for pattern matching that we haven't already discussed that you think C++ developers are going to find really useful?
Specific use cases for pattern matching. Yeah, I mean, I guess we haven't quite discussed trees all that much.
Okay.
But pattern matching comes up in tree traversals, but also tree manipulations quite a bit. And so, so one of the benefits of pattern matching is that it allows you to nest patterns, which works exactly like how you nest values, right? Like when we build values, we build by composition. You might have some int that you put inside of a pair, which you put as an alternative of a variant, which maybe go into a struct or whatever. So these things compose, and so in the exact similar way, you can build patterns in a composition via composition, and so you can think back to how you built that value and then build a pattern to see like do I have that thing. And so with the tree, it works in a similar way as well, where I might say like, oh, like check if the thing on the left is so in an expression tree, for example, like an arithmetic expression tree, if you were to perform some simplifying operation, you actually need to look deeper than one level down to be able to figure out that you actually can do simplifications.
Okay.
I wish I had a concrete example to share with you guys, but I think it's concrete enough, right? Where, so like if you say like on the left, I might have an int, but I need that thing to be 0, and if I have a plus, then just return the right-hand side, right?
Sure.
And I need to be able to do multiple levels of inspection before I can actually make this decision.
Right.
And so this kind of stuff comes up a lot in tree manipulation. Specifically, one of the poster child for it is red black tree rebalancing. You can, so with something like a std map, which keeps track of which has a red black tree underneath, it actually consistently rebalances its tree to keep the height at a reasonable height.
Right.
And the process for that, the process for which that happens is you inspect the structure of your children. And so it would be like if you have left like red, and then on the red you have a black and a red or something like that in some orientation, then you can reorient that such that we restore its invariant. And the code for it actually turns out that there's actually like four cases of the structure that you're looking for of the children, and then all of them actually emerge to the same structure. And so the code for it ends up being like like 10 lines of code.
Right.
As opposed to oftentimes when you look at C++ or Java examples of red-black trees, there's a left rotate function, rotate right function, left rotate function, and all this kind of stuff, which just gets very big and very complex as to how you reason about this code. And so it allows you to think structurally when you actually modify these trees and things like that. So that's a use case that I think comes up quite a bit.
Okay.
I was wondering if the type matching feature can match multiple types, and if so, does it then work for multi-method dispatch?
Yes. Yeah. So it's actually not included in the paper today, but the intent is that we allow matching multiple values.
Okay.
And so you want to be able to say inspect A, comma B, comma C, and then give it, which would introduce an implicit tuple-like thing, and so you would put square brackets around your pattern to match the multiple values. But if those happen to be variants, for example, you could do double dispatch.
Right.
So, and
so
that would,
okay. Sorry. Yes. Go ahead.
Yeah. So it would. So it would basically do tuple matching of those things. But remember, like each pattern can still answer the question of like, does this thing match? Right? And how that gets optimized underneath, like we can do whatever. Compilers will have full power to do whatever they need to do to make that fast. But I think like in terms of performance, I think we have strictly more information than we did before,
Right.
Which I think is a good thing.
Yeah, I see that it gives the compiler more semantic, I guess, context for what you're trying to do. It doesn't just see a block of if statements.
Exactly. Yep.
Yeah.
Right.
Yeah. It's very difficult for compilers to sift through arbitrary Boolean expressions.
Right.
And to deduce meaning from it.
So sorry, Rob, were you going to go?
I was going to ask that question, but you can go ahead.
Go for it.
So we had Herb on last week, and he talked about his reflection and metaclasses proposal.
Right.
You said you have a library implementation of this. Do you think that library implementation would be any different if you had reflection and metaclasses, or would the proposal change at all when those are available?
I think I think my answer would be no, probably.
Okay.
Reflection, I'm somewhat familiar with. Metaclasses, I'm not that familiar with. But one of the issues with the library solution really is the lack of notation available. And so if you look at a pattern inside the library, like they're all just function calls, right? And so like there's no, like it's very hard to look at a pattern and deduce what the structure of it is. Whereas with the added notation for square brackets and angle brackets for types and things like that, when you see something like angle bracket, point, close angle bracket, open square, x comma y, close square, you can kind of like visually see, okay, I'm matching a point, and then I'm going to destructure that into a tuple-like thing. When you just see, alternative open paren, destructure open paren x comma y, like it just looks like a sequence of function, like nested function calls, and it's hard to kind of deduce visually what's happening there.
Right.
And I don't think metaclasses gives you like ability to add new syntax.
Yeah, I don't think so either. Yeah.
Yeah, and so part of it is visual inspection, and so I don't quite think that it would help much in this case.
That makes sense.
Yeah.
Well, it's been great having you on the show today, Michael. We'll definitely keep track of the progress with the proposal going towards C++ 23. Sounds great.
Yeah, thank you. I guess we haven't mentioned the number for the proposal.
Oh, yeah, go ahead.
It's P1371.
1371.
Yeah.
Okay. Well,
Very
good
cool.
luck at the Cologne meeting.
Yeah, thank you very much. Thank you for having me on the show.
Thanks.